How to subnet in decimal. So this video is going to be carrying on from the previous video, and in the previous video we looked at subnetting math in binary. However, when we subnet in binary, it does take a while in order to find out the subnet mask values. It takes time to do the binary to decimal conversions as well. And in the ICD-1 exam, we won't have time to do all those conversions. Now this video shows how we can subnet in decimal and show some shortcuts to subnetting math, making it easier and making it more quicker and more efficient. So just as a recap, in the previous video we looked at how to subnet in binary, and this involves converting the whole subnet mask into binary, calculating the number of bits we need to borrow in order to provide the correct amount of subnets, and then changing zeros to ones, and then converting these subnet masks back into decimal. However, we also looked at an easier way that we can do this to make subnetting in binary more efficient, and that is that when we're subnetting in binary, there's no need to convert the whole subnet mask into binary. So if you think about it, if we were given a class B mask of 255.255.0.0 to work with, there's no point of us trying to convert the first and second octet into binary, because they will not change. They would just be converted back into 255. What we need to focus on, we need to focus on the octets that will change. So the second and the third and fourth octet, which may change. And so we would convert those into binary, find out the binary equivalent, and then convert it back into decimal. So as an example, if we were going to borrow 5 subnet bits, 5 host bits, to put 5 host bits for our subnets, then we were just focusing on the third octet. If we were going to borrow 10 host bits for our subnet part, then we'd focus in on the third and fourth octet. And so by focusing on the interesting octets, it makes our binary conversion much quicker. However, it still takes time to draw out the table, and it still takes time to then look at the table, write down how many binary ones we're going to need, and then to convert back into decimal. And if you think about it, if let's say as an example, if we were borrowing 10 binary ones from the host part, that means that there's no point of us trying to look at the third octet, because that third octet, which is 8 bits in length, will have 8 binary ones, which will convert back to 255 anyway. So then to make it even faster, we can just focus in on the octet, which is neither 0 nor 255, convert that to binary, and then convert it back into decimal. Because we know that if a subnet mask octet has 8 binary ones, it's going to convert back to 255, as shown by these 2 octets over here. So that's another shortcut that we can use to make subnetting easier. However, so as an example, if we were given the class for network of 192.168.1.74 to subnet, the client requirements say that we need to have 30 subnets with 5 clients per subnet, and the original class and mask is /24, so 255.255.255.0. In this example, we would only have to focus in on the last octet and convert that to binary, and that's the only octet that's going to be changing. The first 3 octets will not change, so there's no point of us trying to convert those 3 octets into binary, because they'll just convert back to their original number. So in this example, we know that we're going to need to have 5 binary bits to create 30 subnets, and that leaves us with 3 host bits available, which give us 6 usable IP addresses. That means that the last octet will have a binary value of 5 ones and 3 zeros, which gives us a /29, which gives us a decimal value of 248. So that means that the subnet mask will be 255.255.255.248, and since the last binary one lands on 8, that means that our increment is going to be 8. That means that the first subnet is going to be 192.168.1.0/29, and then the next subnet is going to be 192.168.1.8/29, and the range of IP addresses, so the subnet broadcast address would be, for this subnet, 192.168.1.7, one less than the next subnet in line. The first usable IP address will be one more than the subnet ID, so 192.168.1.1, and the last usable IP address would be one less than the subnet broadcast address, so 192.168.1.6. However, even though this is still pretty fast, it's still not as fast as you want it to be. We still have to do some binary conversions, and we still have to convert from binary into decimal. However, there is a much easier way. Instead of using a binary conversion, we can just use all decimal. And so the way it works, if you think about it, unlike a IP address octet, a subnet mask octet can have one of 8 values. And the reason why is because with a subnet mask octet, a subnet mask octet consists of binary ones on the left, followed by a group of binary zeros. And so it's different to an IP address. So with an IP address, we can have binary ones and zeros mixed. So with an IP address can have value from 1 through 255. With a subnet mask, it can only have, each subnet mask octet can only have a value from can only have one of 8 values, depending on how many binary ones exist in that subnet mask octet. So instead of converting to binary, what if we just, since there's only 8 values, wouldn't it be better and quicker if we just memorize these 8 values and choose one of these 8 values based on how many subnet bits or how many binary ones we have in that subnet mask octet? And then to calculate our increment, we can just subtract that value from 256. So these are the 8 values. So as an example, imagine this is our subnet mask. So 1, 2, 3, 4, 5, 6, 7, 8. So we know that each subnet mask octet consists of 8 binary bits. When one of the binary bits is 1, that subnet mask octet will have a value of 128. When two of the binary bits are set to 1, that subnet mask octet will have a value of 192. When 3 of those binary bits are set to 1, that subnet mask octet will have a value of 224. When 4 of those bits are set to 1, that subnet mask octet will have a value of 240. When 5 of those bits are set to 1, that subnet mask octet will have a value of 248. When 6 of those bits are set to 1, that means that subnet mask octet will have a value of 252. When 7 bits are set to 1, it means that subnet mask octet will have a value of 254. And you probably didn't really know this, but when 8 bits are set to 1 in the same subnet mask octet, that means that subnet mask octet is going to have a value of 255. And so to really see this in action, let's go through some examples. So I'm going to pause the video very quickly, going to get up some examples, and then we'll be back in a moment. So now we're back, and let's move on to the first example. This first example, we're going to use the class for network 10.0.0/8. We need to have 1,000 subnets, and the client needs 1,000 hosts per subnet. And they also said that we want to maximize the number, so maximize subnets, maximize the number of subnets they have. The first thing we're going to do, we need to calculate how many bits we're going to need to provide 1,000 subnets and how many host bits we're going to need for 1,000 hosts per subnet. So to do this, we just go up in powers of 2 until we get to a number which is greater than the number of subnets we need, or equal to. So 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, 2 to the power of 7 is 128, 2 to the power of 8 is 256, 2 to the power of 9 is 512, and 2 to the power of 10 is 1024. So as you can see, when we have 10 subnet bits, it means that we would have enough subnets for 1,024 subnets. That means that we would also need to have 10 host bits. Host bits. Now, they said that we want to maximize the number of subnets. So to do this, we need to think about how many bits are in a subnet mask. So in a subnet mask, there are 32 bits. 10 of those bits have to be reserved for the host. So that brings, so 32 minus 10 is 22. So that leaves us with 22 bits. So that means that 22 minus 8 is 4. So we have 8 network bits. That means we can have 14 subnet bits for our subnets, maximizing the number of subnets, while still having 10 host bits available to address 1,000 hosts per subnet. That means in this example, we'll have 14 subnet bits and we'll have 10 host bits. So this gives us a 14 plus 28, a /22 mask. So quite that very quickly. So new mask /22. Now, the original subnet mask is 255.0.0.0. And we're adding 14 more binary ones into our subnet mask. The second octet is going to consist of 8 binary ones, which gives us a 255. And the third octet is going to consist of 6 binary ones, which if you go back to our table, we have 6 binary ones in a single subnet mask octet. That gives us the value of 252. 0, which is a /22. Now, to work out our increment, all we do is look at the interesting octet. This is the octet with that is carrying the last binary one before we have a group of consecutive binary zeros. In this case, it'll be the third octet, and we'll subtract that value from 256, which gives us 4. So our increment is going to be 4, and the increment is going to occur in the third octet, because that is the octet in the subnet mask which is carrying the last binary one. So now, let's work out our subnet. So the first subnet is going to be 10.0.0.0/22. The second subnet is going to be 10.0.4.0/22. And the third subnet is going to be 10.0.8.0/22. So these are the subnet IDs of our subnets. Now, let's work out the range of IP addresses. So let's work out, so we already have the subnet ID. Let's work out the broadcast address. And like I said before in the previous video, the broadcast address is one IP address less than the next subnet ID. Now the next subnet ID is 10.0.4.0. That means that the IP address before this is 10.0.3.255. So 10.0.3.255. The first usable IP address is going to be one more than the subnet ID, so 10.0.0.0.1, and the last usable IP address is going to be one less than the broadcast address, so 10.0.3.254. So as you can see, very, very simple. So we're doing the exact same thing here. Let me move this, we can bring this up. So as you can see, we're doing the exact same thing as we're doing with binary, but because we're doing it in a much more efficient and faster way. Instead of having to do the binary conversions, as long as we can memorize those 8 values, and you wouldn't even have to memorize them. I mean, like in the exam, they give you a whiteboard to work with. So all you would do, you draw this table on your whiteboard, so that as you're working through your subnetting questions, you can then reference this table and go, okay, if I've got 8 binary ones in an octet, that'll be 255. If I have 6 binary ones in one octet, that'll be 252. 3 binary ones will be 224, and so on. And so like this, I know that my new mask is going to be a /22. That means I'm going to have to add 14 binary ones to the original subnet mask. Each octet has got 8 bits. That means that the second octet is going to be 255, and the third octet is going to be 252 because it's going to have 6 binary ones, which gives me my 14 more binary ones. And now to find out the increment, I just subtract that from 256 to get 4, and the increment of 4 occurs in the third octet. Okay, that's the octet in the subnet mask which carries the last binary one. So in this case, my first subnet is going to be 10.0.0.0/22, and the next subnet in line is going to be 10.0.4.0/22. Now let's move on to the second example. So in this example, we're using a class C address. We need 5 subnets of 30 hosts per subnet. So in order to get 5 subnets, how many binary bits do we need to change to 1? So 2 to the power of 1 is 2, 2 to the power of 2 is 2, and 2 to the power of 3 is 6. So we're going to need to have 3 binary bits for our subnets, and how many bits do we need for our hosts? 2 to the power of 4 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32. This means that we're going to need to have 5 binary bits for our host part and 3 binary bits for our subnet part. And so that means 8 bits, which is the exact number of bits we have available to play with for class C mask. So class C mask, 24 bits represent our network, and we have 8 host bits. That means that we will change 3 of those bits to subnet bits, and 5 of the bits will stay as host bits. So write that down: 3 subnet bits, 5 host bits. Okay, and let's write down the original mask. So 255.255.255.0, which is a /24. Okay. Now the new mask is going to be 255.255.255. The third octet, we're going to have 3 binary ones. So if I go back to my table, 3 binary ones gives us a value of 224. Around 224, which gives us a subnet mask of a /27. Because we already had 24 binary ones, we're adding 3 more binary ones to our subnet mask, which gives us a /27. And let's find out the increment. So to find out the increment, we subtract 224 from 256, which gives us 32. So our increment is going to be 32, and that's going to occur in the 4th octet of our IP address, since the 4th octet is the octet that carries the last binary one. And so normally you will know it to carry the last binary 1 because it's either a value that isn't 0 or 255, or if it's a 255, it's the next octet in line is completely all zeros. That means it's carrying the last binary 1 bit. And so by working out the increment, we can work out the subnet IDs of all of our subnets. So the first subnet will have the subnet ID 192.168.190/27. The next subnet in line will have the subnet ID 192.168.1.32/27, and then the next subnet in line will have the subnet ID 192.168.1.64/27. Now that we've worked out our first 3 subnet IDs, let's work out the ranges. These are the range of addresses for that subnet. So the first thing we're going to do is work out the broadcast address, which is going to be, the broadcast address is always one IP address less than the next subnet ID. In this case, it's going to be 192.168.1.31. The first usable IP address will be one more than the subnet ID, so 192.168.1.1, and the last usable IP address will always be one less than the subnet broadcast address, so 192.168.1.30. And so as you can see, we're working out these subnets much quicker than what we were doing in binary. It's much faster. You know, it's becoming easy now. As long as you have that table in hand, it makes converting, and it makes finding out the new subnet masks much easier because we have the table in hand. So we know. So from looking at the table, instead of having to write out binary 111.0.0.0.0 in binary and then convert it from binary back into decimal, I can just look at my table and I can see that when I've got 3 binary 1s in a subnet mask octet, that gives me the value of 224. To find out my increment for my subnets, I do 256 minus 224, and now 32 is my increment. And so now to find out the subnet ID of the next subnet, I just increment 32 in the 4th octet. And again, we do in the 4th octet because if we look at the subnet mask, it's the 4th octet of the subnet mask which carries the last binary 1, which means I need to increment the 4th octet by 32 to find out my new subnet ID when I look at my IP address. Now the third example is a bit different. In this third example, we're going to work backwards. So this example says that we know the IP address of the host and we know a subnet mask. Now we need to find out firstly what subnet it's a part of, as well as the first usable IP address of the subnet. And so in this case, we don't need to have the client requirements. All we need to do is find out the increment. So again, to find out the increment, all we do is do 256 minus the interesting octet. Interesting octet is the octet which carries the last binary 1, which is the 4th octet here, minus 128, which gives us 128. And now we start to list all of our subnets. So the first subnet is going to be 10.9.192.0 / there's going to be a /26 because we have 24 binary 1s and then 1 binary 1 in the 4th octet. Oh, sorry, /25. And now the second subnet is going to be 192.128. So by using a /26, this only gives us 2 subnets available to us. Now we need to determine which subnet this host lives in, and if we look at the address ranges, we can see that the host must live in this subnet because it has an IP address greater than this subnet ID, but an IP address less than this subnet ID. So now that we found out it lives in this subnet, to find out the first usable IP address, all we do is add 1 to the subnet ID. So 10.9.192.1. So that's the first usable IP address of this network. So the first valid host on this network has this IP address. And as you can see, by using these shortcuts, it makes subnetting much easier. Now, I found that out within a matter of 1 or 2 minutes. And much quicker, much more efficient. And much more easier to understand than subnetting binary. In binary, we have to convert into binary, then convert from binary into decimal, and it's a very long process. So we have reached the end of this video, and in this video we've seen how we can subnet in decimal. We've seen the shortcuts that we can use to subnet in decimal, making subnetting easier. And just as a quick review, we know that a subnet mask octet, because of the way a subnet mask is organized, so a subnet mask octet cannot have interchanging 1s and 0s. All the 1s are on the left and all the 0s are on the right. That means that depending on how many binary ones we have, that subnet mask octet can have one of 8 values as listed here. And so all we have to do is that if we've got 3 binary ones in our subnet mask, we just have to memorize the number we get when we have 3 binary ones. And so just to be clear, the way I got these numbers is that when we were drawing our table, we draw up in powers of 2, so 128, 64, 32, 16, 8, 4, 2, 1. These are this is a table that we drew when we were doing our binary conversions. All this is that so binary 1 here, when we have another binary 1, we just add 128 plus 64, which gives us 192. When we have 3 binary ones, there's 128 plus 64 plus 30, which gives us 224. These numbers are based on that table and based on how many binary ones we have. So instead of having to memorize that table and have to do the conversions, just if you memorize these values, it makes subnetting much easier, because then we know that if we have, as an example, 4 binary ones or 5 binary ones, then we're going to know the value of the subnet mask octet. And so once we have the value of the subnet mask octet, to find out our increment, to find out the subnet ID of the next of the first subnet, then the subnet ID of the second subnet, all we do is subtract that in the interesting octet, the octet that is carrying the last binary 1, we subtract that from 256 to give us our increment. And in this case, we increment in the matching we increment in the octet of the IP address based on the octet of the subnet mask. So by that I mean that in the subnet mask is the 3rd octet, which is interesting octet. That means that when we go to find that when we start to list our subnet IDs, we increment them by 4 to find our next subnet in line in the 3rd octet, because that's the octet on the subnet mask which is carrying the last binary 1. So we increment by 4 in the 3rd octet of the IP address to find out our next subnet ID. And so it makes subnetting much easier, much more efficient. So we reached the end of this video. I'll probably make 2 or 3 more videos on subnetting, so that we can now look at variable length subnet masking. We can look at actually assigning these subnets to WAN links and to VLANs, and we can now look at different subnetting questions. And instead of us being given the requirements, look at different subnetting questions that we may face on the exam, and how to work on those questions and how to find out the answers based on the subnetting decimal math that we've covered in this video. I hope this has been informative for you, and I would like to thank you for viewing.